Hi everyone, welcome to this problem, which is chapter 2, case 2. This is the third problem on the homework. Um, I have already set up the decision variables and the objective functions and stuff, but and I will go through this. Now, this problem is again pretty similar to the chairs and tables problems that we did. You have two decision variables here, just like chairs and tables. Then you have some three different departments that you need to that you have time, maximum amount of time that you have available in those departments. That's maximum that you can do. And then of course we added some extra constraint here, which we'll go over in a second, which is about how many BP200s you need to manufacture, right? So with that here, the biggest thing that you have to do in this problem is coming up with the profit value. So you know that you're able to sell each BP100 for that I think it's $2,500, but you know that they are selling to resellers and they give them a 30% discount, so they sell it to them at 70% of the cost. So 70% of 70% of of 2400 is in fact 1680, and all the total cost, the material costs for the four different things that you're doing, and the labor cost. So this is labor cost for each of the the three different items that you're adding, plus the packaging, and the same goes for everything. So if you add up everything, the profit for a BP100 comes down to 371. So 70% of 2400, that's the sales price. These are all the costs put together, 1309, and that comes to 371. And the total profit similarly for BP200 will be 461. All right, so those are the numbers that we're going to use to write our objective function, right? So when we write our objective function, we say that the objective is to maximize 371 times the number of BP100s plus 461 times the number of BP200s that we are manufacturing, right? So that's our objective function. Now for the constraints, so we know that we have 600 hours of machining and welding time, 450 hours of painting and finishing time, and 140 hours of assembly, test, and packaging time. So when we write out these constraints, just remember that we need 8 hours of machining and welding in total for BP100. So that includes all the different the different individual pieces that you need to do. If you add up all the times, comes 8 hours for BP100 and 12 for BP200, 5 hours of painting and finishing here, 10 hours of painting and finishing here, and assembly and package basically takes the same amount of time, right? So that's the three constraints that we have here. And the fourth constraint essentially is that if you look at the constraint here, it says, right here. Consequently, so BP believes that the unique capabilities of BP200 can help position BFI as one of the leaders. So consequently, he stated that the number of units of BP200 produced must be at least 25% of the total production, right? So 25% of the total production, minimum of 25% of the total production must be BP200. It can be 25% or more. So how would you write a constraint like this? So coming back here, so the BP200 requirement constraint, right? Again, I'm sure you all did this correctly, but just to go over it, you say that the number of BP200s that you manufacture has to be at least 25% of the total number that are manufactured. And what are the total number manufactured? Well, we don't know. That's part of what we're doing in the problem. So it'll be total number of BP100s manufactured plus the total number of BP200s that are manufactured, right? So this is what the constraint looks like. So BP200 has to be at least 25% of the total. So this basically boils down to, so you can distribute the 0.25 in. So it'll be 0.25 times BP100 plus 0.25 times BP200. And then you subtract this whole thing and bring it to the left-hand side, you'll be left with this constraint. So 0.75 times BP200 minus 0.25 times BP100 has to be greater than or equal to 0. And that's the constraint, all right? Now, the textbook does say that you should use the graphical method for this, but I specifically said you can use the, if I remember correctly, I did say that you can use solve with Excel, right? So I wanted you to solve with Excel, so that's exactly what I'm going to do here too. So let's solve this with Excel. Okay, solving with Excel, so I'm gonna, let's get this going. So we have BP 100, BP 200, right? Then you have the left hand side, right hand side. Okay, decision variables. So these are our decision variables right here. And then the objective, you know that this is 371 and 460, right? Yeah, man. Let me, right? And then the constraint. So you have machining and welding. So maybe I'll just copy this out like that. These are the 4 constraints that we need. Right? And for the machining and welding constraint, it is 8 times this, 12 times this is less than 600. 8 times 12 times is less than or equal to 600. Right? Then you have 5 and 10 less than 450. And then 2 and 2 is less than 140. Right, so those are the 3 less than or equal to constraint. For the greater than or equal to constraint, it's negative 0.25 here and positive 0.75 here. This is greater than or equal to 0, right? So these are the 4 constraints. Now, if you did solve this with graphical method, I will still give you credit for it, but I mean, you didn't have to. All right, so let's do that. Let's do that. So that's the objective. So let's write the formula for the objective. Let's write the formula for the objective. Be some product of the decision variables, which we will make absolute references, right? So decision variables have to be absolute references and the corresponding coefficients. Shoot. All right. I know. I'm a little bit obsessed about this. So, okay. So all the formulas are in. So let's go to the solver. Go to data. Solver, right? So profit maximization problem. So we'll keep it at maximize. So that's where my objective function is. D4. Changing variable cells. These are the 2 changing variable cells. I'm going to keep that. And then the constraints. So we'll have 3 constraints that are less than or equal to, those 3 numbers, and 1 greater than or equal to constraint. Right? Everything is good. Otherwise, let's click on solve. Now, yes, the final solution does come out to be a non-integer case. So yeah, there are 2 options here. One is you can keep this, because this is 16.67, you can round it up to 17. But if you round it up to 17, you won't satisfy some of the constraints. Let's say that I round this up to 17, right? You'll notice that we'll need 604 hours of machining and welding, right? So the one thing, or you can just round it down to 16. That's the other option, in which case you have all the constraints that are satisfied except for the body plus requirement, because you want at least 25% of the total to be body plus. But for the sake of argument, I'm going to keep this as 16. And I'm sorry, we'll just keep it at 16.67. So let me just do that. So let's assume that we can make 16.67 and we are able to sell the 0.67, however it works out. But this is one of those constraints. Now, in reality, how would you make it so that these numbers are always integers? Well, there is a way to do it. If you go to solver, what you can do is you can add a constraint where you can designate this cell and say that this has to be an integer, and you can do that. But that's something that we'll come back to later on in the semester. But for the timing, I'm going to leave it here, and that'll be our answer. I know it didn't come out to be an integer, but that's okay. Well, let's look at the questions that were asked, right? It said, what is the recommendation that you have to produce? Now, one reason why this might not be a problem, 16.67, is because let's say that there's a continuous manufacturing thing where right now you're planning for this month, but then anything excess left over will be rolled over to next month, and then you plan for next month and plan for next month and so on. Within like 3 months, you would have caught up and you'd have one extra unit of BP200. So, so in that case, that's okay. Let's say, what is the recommended number of body plus 100 and 200 machines? So I will say that 15 and 50 and 16, right? Or if you say 16.67, that's fine too. How does the requirement of number of body plus 200 produce? How does the requirement that the number of units of body plus 200 produced at 25% of the total production affect profits, right? So what if this constraint did not exist? So how does this particular constraint affect our profits? Well, if you look at this constraint, you'll notice that this constraint is, this constraint is a constraint that is strictly satisfied. What that means is that this is a binding constraint. The left-hand side and the right-hand side are exactly equal to each other. So it has a huge effect on the profit. So for example, if I go to solver and I got rid of this constraint, for example, so right now the profit is 26,233.33, right? So okay, let me go here. I'm gonna copy this and I'm gonna just the values. All right, now if I go back to solver without that constraint and I solved it, you will now notice that we would make way fewer BP200s and we'll make way more BP100s, and the difference in profits is 26,870 minus 20, so $636 more in profit. So this constraint here is having a effect on the profit. So how much more or less? So this divided by that should give you about 2.4. You're making 2.4% less than you were making before, right? Where should efforts be expended to increase in order to increase profit? So that's where you look at which of these constraints are binding. So you'll notice that let me go back to adding this constraint. Let's add this constraint here. Okay. So 26, right? So if you notice that this is a binding constraint, this is not a binding constraint, and this is not a binding constraint, right? So how can we increase our profits, right? So assuming that we cannot touch the 25% requirement because the boss wants it, machining and welding. So if we can hire more people in machining and welding, that's where you're going to increase in profit. Now, the other way to do this is to generate a sensitivity chart where you'll notice that because these are non-binding constraints, their shadow price will be 0, but because there's a binding constraint, you will have a shadow price, right? The same goes for here. And then you'll notice that machining and welding is where if you can have more time with machining and welding, you'll make more in profit, right? So that's the idea here, all right? So this is problem number 2. I'm going to end this video here. It's already 15 minutes long. And again, I'll post everything. You should have seen everything posted once this video goes up. All right, take care.